8.97
8.9,
and 31.
31, that's fine. So your unsupported length, which is the total length of your column, which is 17. What is the relation? Your LB smaller than LP or in between? So LB in between LP and LR, that's right. So your design bending moment equal, as I remember, CB Phi, I think, M plastic minus Phi BF LP minus LB. That's right?
LB minus LP.
Yeah, I'm sorry. Anyway, so open your table. CB will assume it 1. That's fine. Phi M plastic. Open your table for this cross section. You can figure out what is the value of Phi M plastic as a one term.
227.
227. Minus. I think BF is given alone. So Phi 0.9. BF, what is the value of BF?
3.67.
3.67. LB, which is 17, minus LB, which is 8.9. You can get your design bending moment, 227 minus 0.9 times 3.67 times 17 minus 8.9. Your value is 225. Keep feet. So go ahead and put your values. P ultimate divide Phi Pn, you don't need to put your numbers, you can get this number directly, 0.51. Plus 8/9 time M ultimate X from structure analysis, 107.1, divided by your design bending moment, 200.25. What's your value? Is it smaller than 1 or greater than 1? So point plus. Wow. Your value 0.985. First, it's smaller than 1. Your cross section is safe. Your value 0.985, very close to 1. Your cross section is more economic. So design of frame members, nothing new, but we need to combine everything we learned before. Design of column, design of beam, both of them together in this interaction equation.
Dr. Raymond, so the only thing that I have a question about is the CB part that we assume to be 1, but it has to do with, I mean, I guess we're used to doing the horizontal beams, but the vertical beams, all the rules still apply? Like unbraced, it's unbraced and it's at the center.
We are talking about the compressive flange. Your beam, your column is behave like a beam. It's not like a vertical member, so it's column. No, we have bending moment, and this moment will make your flange under compression. So go ahead and open your table for CB. I assume that it's 1, but maybe for concentrated load, for simply supported constraint here and here, maybe different value.
1.32.
Yeah. I assumed it 1 because I don't have time to look for the table. But go ahead and open your table. I think we have concentrated load supported here and supported here only. The table can tell you what is the value of CB, exact value. Okay?
If you think if we would have had the MUY, Do you think the value would have been more than 1?
Yeah,
Yeah.
sure. Yeah. Because you have compression due to this one and this one and this one, all of them together will make your cross section unsafe. Sure.
When I plugged in the other CB, it made 0.87.
0.8, still safe.
Still safe.
That's fine. You know, yesterday there is one from a company called, I'm not sure what's the name of the company. He said, hey, during his BE exam, professional engineering exam, there is a sentence over the exam say, assume any missing data. If I told you, hey, we have a cross section of beam, reinforced concrete beam, but I did not say what is the value of FC prime, and go ahead and assume this value, anybody can assume it 100? No, the normal or the common value of FC prime, what is the common value? 3,000, 4,000, 5,000, that's fine. So assume any reasonable value. So CB, hey, I don't have time. Time is out. I cannot look for what is the value of CB. Okay, go ahead and assume it 0.1. No, 1. Because your value 1.1, 1.67, 1.33, 1.25, 1, something around this value. You know what I mean?
Yeah.
In design, life is easy until you are safe. But if you are not safe, no, be careful about your numbers.
Doctor, I might have another question.
Yeah.
So somehow, like, if on RESA we drew the elevation view,
This RESA is 2D.
2D.
We cannot
Okay.
make 3D structure. Next semester, we will purchase 3D license, so we can do space frame. For a space frame, we will have P, MX, and MY, and we can.
We won't be here next semester.
Look at
See a straight line.
Just a review, how to design. Actually, we cannot design. You will need to select trial cross section. Go ahead and choose a trial cross section. And based on this cross section, do your calculations. If your value smaller than 1, you are safe. Then, what is the value for this left side? If this value close to 1, like 0.9, 0.85, 0.95, that's fine, you are economy. You selected an economic cross section. But if your value 0.2, 0.1, 0.5, you are very far from 1, that means your cross section is more safe. So if the results is not very close to 1, try another cross section. Continue the process until a shape is found that gives an interaction equation result less than 1 and close to 1, greater than 0.9, 0.9, 0.91, 0.99, that's fine. Any question? So today we can design any member in your truss, tension or compression. Even we can design your column of your truss. Each member in your truss double angle or single angle. Your column in your truss W shape. We can. If your main system is frame, hey, we can calculate our dead load, live load, wind load, make combination, make structure analysis, and we can get normal force, shear force, and bending moment. If you would like to design this column, okay, we have normal force, which called B ultimate. We have bending moment, which called M ultimate X. We can assume cross section and make check. For this beam, we cannot call it beam right now. For frame, every member called beam column, because we have normal force and we have moment at the same time. So each member in your frame called beam column. Why? Because we have moment, we have normal force at the same time. Until now, we did not talk about anything related to your connection. We have this connection. So we have vertical column, we have inclined member, which is double angle, we have inclined member, which is double angle. We need to figure out how many bolts you need here. And something called gusset plate to make this connection. So we need to figure out how many bolts needed for each member. What is the shape of your connection? What is the strength of one bolt? All of this stuff will be covered next week. And we will learn a little bit from a software, how can I draw my connection when there is a connection. Any question?